Okay, perfect. So good afternoon, colleagues. So my name is Mikhail Komarov. I'm very happy to see you participating in the roundtable on opportunities and challenges of distributed ledger technology implementation. I'm professor at the Department of Business Informatics, Graduate School of Business, National Research University Higher School of Economics, academic supervisor of master program in e-business and digital innovations, and also head of project group on distributed ledger technology funded by the Graduate School of Business in 2020. So within our project group, I just would like to share a few words. We are analyzing different approaches for modeling of different distributed ledgers. I'm extremely happy that our key expert and partner of that research, Professor Ali Sunyaev, today is with us. Also participating in this roundtable. We've already performed Delphi study of parameters and characteristics of DLT. We have collected requirements from the railroad industry, banking industry, energy sectors in terms of conceptual modeling. We have analyzed correlations and influence of parameters and characteristics of DLT and Internet of Things. We've also analyzed potential usage of DLT for sentiment analysis, quite interesting area, to be honest, when DLT actually helps to store initial database for further sentiment analysis. We've analyzed the security mechanisms applied for internal use in the Android operating system and the communication between Android operating system and the remote servers, which is important also for the DLT implementation. Of course, there are many things to do. And currently with our partners, with the research group led by Professor Sunyaev together, right, we're in the process of analyzing several interesting, important topics. And I'm sure that today's roundtable, or more like a workshop as well, will bring many interesting ideas for our future joint work. Colleagues, I would like to inform you about some, let's say, official procedures, right, that we processed all the personal data according to the Russian legislation, Russian federal law, and we tried also to comply with the general data regulation protection rights, right, of the European Union. So also our current session is recorded. If you do not want, to be recorded, so you can switch off your video. Anyway, a recorded session will be uploaded afterwards as a YouTube. I ask all of you before the session, for your confirmation, so I received your confirmation for that. Today we have many interesting topics which will be covered, and discussion will be related to short presentations of each speaker devoted to specific topics from the questions indicated for the roundtable. We will also attend this to ask 1-2 questions, depending, of course, on how intense is our discussion, right, and our timing. I was also informed that we can spend a bit more time if necessary, but anyway, I recommend that maximum duration of the presentation is not more than 10 minutes, something like that, with short discussion afterwards by the speakers. Yes, I will also indicate you when we have like 1-2 minutes left, so I will say that it's like 1-2 minutes left, right? I'm sure we'll have very efficient, interesting, productive roundtable. Colleagues, I also ask to introduce yourself, let's say, in a more detailed way, because I will introduce you shortly, right, one by one, if you don't mind, so that we actually go directly to, to the work of our roundtable. I also happy that to see that we've got colleagues from different campuses, from HSC, and I'm sure that after this roundtable, there will be also many questions which you might receive, via email from external audience, right? Anyway, once more, thank you so much, and let's start. So I would like to give a floor to Professor Director of the Institute of Applied Informatics and Formal Description Methods, Karlsruhe Institute of Technology, Professor Ali Sunyaev from Germany. So Ali, the floor is yours.
Yes, thanks. Thanks, Mikhail, and I just have to say a couple of words in Russian. So, здравствуйте. Спасибо за приглашение. So, do you see my slides and my mouse as well?
Yep.
Okay, great. So, Mikhail asked me to give a short presentation, and as I understand, it's kind of more an introduction talk to the topic. So that's why I decided to call it Trade-offs between distributed ledger technology characteristics. And if we actually kind of think of DLT, there are still a lot of people who say, well, it's just a hype. And that's why I found this quote from Mr. Gates, who said, like almost 30 years ago, that internet is a hype. And you know what, you can't actually blame him for this, because first you see that smart people are able to change their mind. And second, well, there were not very many people who thought 30 years ago, who thought that internet will become such a success story. So what is actually distributed ledger technology, or why do we deal with this? The core idea is actually concerning the decentralization or the distribution on all the possible levels, like technical level, organizational, political level, etc. And if we take a look at the internet right now, it's kind of, you know, not the way it was actually designed. So it became more like a centralized network where we have some central computers, some central servers that have some power, and other computers act like clients and send some requests to the server and get responses. And the most prominent example for such a network are probably web services, and that's for sure the majority of the internet services we use currently. Then there is kind of partially centralized or partially decentralized network, where the hierarchy is broken down a little bit. Well, we have further servers that they on their own can handle requests from clients, but they are still dependent on some other servers. And last but not least, we have real decentralized networks where all participating computers are kind of the same or have the same rights. Well, of course, they are not the same. They have different storage and computing power, but with regard to the acting within the network, they are the same. And the most popular example are the peer-to-peer networks. So the question is, what does actually DLT play a role, or what kind of role does DLT play within this decentralization? And thinking of DLT, we understand that this is kind of a technology that enables us to operate append-only distributed databases in kind of untrustworthy environments, right? So all this internet, all these networks are seen as untrustworthy environments because you deal with different computers, with different nodes, and there might be failures or faults. So think like of your social or professional life. If you deal with people, there is always a person who is not available the time you need the person, right? Or who is not responding to your messages. And you don't even know why, maybe for reason, or maybe there is no reason. So there is even maybe persons who play unfair for purpose. So with DLT, we are now kind of able to tolerate, right, all these possible faults and risks. So we are able to agree on the information that is going to be added to this distributed databases, having some parties which may play unfair, or which may crash, or which may not be available. And some of these failures are called Byzantine failures, and this is done through kind of, you know, all this magic happens through some consensus mechanism, which is mostly based on some game theoretical thoughts. So if we have this world where we don't have to care about the data management anymore, it becomes really interesting, right? So if we all participating parties agree on the data, then we can think of the logic we can run on this data. So all the processes that all involved parties agreed on, and if these processes are atomic. That means they don't need any human interaction. You can automate them and enable so-called decentralized applications, which are kind of run on the agreed data management layer. And I'm very happy to present this one because actually Horst as well as Gilbert are co-authors of the recent paper where I got this figure from. The figure is actually from Johann Kranz. So we definitely understand that DLT has some characteristics like high availability, process automation, high integrity or transparency, and there is 3 different application classes where it probably makes sense to use DLT. So the combination of all 3 is for sure the best, but even if there is one of these classes available, that the use of DLT makes sense. So it's access management, it's identity management, think of distributed public key infrastructures, and it's logging, so kind of, protocolling of the transactions. And we see that there is a lot of DLT designs out there, but they are all kind of different. There is no one size fits all DLT design. So if you think of security, like the core 3 goals of IT security are confidentiality, integrity, and availability. So how to keep your data secure from unauthorized access is, with regards to confidentiality, integrity, that your data is not changed or altered during the transmission or after the transmission, and availability is about having the data available the time you need it. And you see that the goals, availability and confidentiality, they are very contrary. Or if you think of CAP theorem that says that consistency, availability, and partition tolerance cannot be achieved in a distributed system at the same time, DLT will not solve this problem as well. So what do we have? We have different concepts of this DLT technology, like, blockchain, that's probably the most popular one, where the transactions are stored in blocks, and all these blocks are chronologically ordered. So every block has a predecessor block and a successor block. We have some concepts where the blocks might have several successor blocks or several predecessor blocks, or we have kind of different acyclic graph structures where we actually do not need any blocks at all, where the transactions directly refer to each other. And here you see some prominent examples for these concepts. And all these concepts have different properties like security, performance, level of anonymity, and all these properties are divided into characteristics like availability, confidentiality, throughput, etc. And you can't have all of them achieved at the same time. So it's always a trade-off. Are you going for more kind of a performant DLT design, or are really concerned with regard to security? So let's kind of dive in deeper a little bit into this one and see it on the example of Bitcoin, which is a very prominent blockchain for cryptocurrency, right? So Bitcoin blockchain is highly available. So every node can participate, and it is, kind of no question that the availability is very high prioritized, but the throughput is very low. So it's kind of, you can do 7 transactions or so a second, which is not high. If you think of Hyperledger Fabric, throughput is like up to 4,000 transactions a second. So it's a completely different number, but it's not as scalable, for example, because if you kind of have more than 10 nodes, it is not be as performant as it is with 5 to 7 nodes. And once we have all these properties and characteristics, what do kind of computer science people, information systems people do? They try to formalize it. So I choose 3 simple examples for you. So if we have a characteristic like scalability, which says that, which kind of stands for the capability of a distributed ledger to efficiently handle decreasing or increasing amounts of required resources. So it means both transactions per second or a number of validating nodes. Then you can see it's a very easy formula. You have 2 configurations and a mean transaction latency, which says how long does it take that the transaction is really written to the database, and you take the throughput of the one configuration divided through the mean transaction latency of this configuration, and divided again through the throughput and mean transaction latency of the other configuration. And what you see here is that Bitcoin and Ethereum blockchains are quite good with regard to scalability, but Hyperledger Fabric is, for example, not. The second very easy example is concerning confirmation latency. It means time span between the inclusion of a transaction in a ledger and the point in time where enough transactions have been included in the ledger so that manipulations are not possible anymore. And what you see here is that we take a number of n transactions and divide the time when the transaction was submitted to the database and the time when it actually was confirmed. And what you see here, for Bitcoin, we have like 60, so like an hour that it takes that you can be quite sure that the transactions is really written to the database. For Ethereum, it says you see 6 minutes, and for Hyperledger Fabric, it's like 2 seconds. So you see that the differences are quite big. And maybe last example concerning the stable block rate, so the number of blocks that have been generated in a period of time, but not appended to the main chain of a distributed ledger. And that's in a very easy formula again from distributed systems and distributed database, where you have mined but not included blocks and divided through the last 1,000 blocks you actually generated. And you see that well, Bitcoin is actually doing quite well, but Ethereum has 7% of blocks that actually are not used later anymore. So now it's becoming more interesting. Okay, so we have kind of 2 different designs. We have one design which was kind of established for high performance. I have high performance, for example, a real-time supply chain, and you have a very high security DLT design that was designed to enable payments. And now you want these 2 designs, these 2 different blockchains, actually talk to each other and exchange tokens. So again, we have, this is called Crosschain Technology, and we have different patterns like manual asset exchanges, notary schemes, and relays or side chains. And all these patterns have different properties like administration, flexibility, and networking. And these properties, again, have characteristics like accountability, auditability, developer support, locking mechanism, routing, etc. So let us take a short dive into the cross-ledger technology. And what you see for manual asset exchanges, it's actually kind of something you know from the real life. You have to find another person that is willing to have the exactly exchange and to do this exchange with you are looking for. And of course, they are not very kind of safe with regard to all these non-atomic swaps, so kind of hardly to have this transaction done in the same time, and you have still to trust the other one that it's not kind of just taking your assets and blocking your kind of access to their assets. Then we have notary schemes. That is also something you know from the notaries with kind of real fiat money, where you go somewhere and exchange this money for other currency. And we have here centralized schemes or decentralized schemes. With decentralized, it means that there is a consortium of notaries, so that the trust is again a little bit more distributed. Then we have sidechains and relay. That's where it becomes more kind of automatic, where we have highly interoperable sidechains that enable this interplay and this cross-ledger intersection on their own, and very prominent examples here would probably be Infinite Chain or Doge Ethereum. And then there's hybrid solutions that combine the side chains with notary schemes. And let me coming to the end and again refer to our publication, where you can see these types of decentralization. First, if you want kind of has this cross-ledger interoperability, one ledger has to find exactly the other one who wants to have this exchange. You can have it in an indirect but still centralized way through a notary, or you can go to a very high decentralized and direct way, which is quite impossible currently, where every kind of, every ledger can talk to to another. And this is something we observe right now, where we have highly interoperable side chains that enable kind of, this indirect and decentralized interoperability. So let me finish my very short talk. Sorry, I couldn't hold the 10 minutes with the value of and the transformative value of such decentralized applications. So what we can kind of observe for the last decades with regard to information technology is that we come from this, centralizations as personal computers, as servers, and then we go to the cloud, which is kind of a centralization as well, but at the same virtualization, but at the same time a decentralization, because all you actually need is access to the internet. And we're coming back with the DLT to this kind of idea of decentralization. And the same we see actually for business. This is how all the enterprises and organizations were kind of organized for decades. Then we have the matrix structure with clear definition who is responsible for what. And now we are going towards decentralized teams. Think of DevOps, think of cloud natives, and so on. All these core ideas where decentralized teams are kind of self-responsible. As usual, references to the end, and thank you very much.
Thank you very much, Ali. Colleagues, attendees, yes, you can write down your questions if you have any chat, so that afterwards, we can discuss them. Colleagues, speakers, is there any questions so far to Ali? Is there any? Or any comments related to the topic? Because I thought that it's more or less a really general introductory talk, to the problems we have with, with the distributed ledgers at the moment. So I assume I don't see raised hands here. So then I would like to pass the floor to Professor Horst Treibelmeier from Head of Department of International Management from Model University, Vienna, from Austria, with quite interesting, I think, application of distributed ledgers. And I already got several questions, Horst, so afterwards I will ask them.
Okay, thank you, Michael. I hope you can see my presentation now. I just shared my screen. I will do my best to stay within that 10 minutes. I also say здравствуйте to everybody, and thank you very much, Michael and Ali, for having me. And I've been doing blockchain research now for a couple of years. My focus is not as technical as Ali's, but I'm more on the business side, and I have witnessed an interesting evolution. I started a little bit before the hype, then around 2015, 2016, 17, we had the huge hype. You can use blockchain for everything. After that, there was the blockchain winter, and people were saying blockchain is completely useless. I mean, some people were saying that, of course, not everyone. And now it's kind of consolidating. And a couple of years ago, I started a project to figure out what kind of blockchain technologies you can really use. And what I'm talking about today is about how you can use blockchain, all kind of DLTs for disaster prevention and recovery. And my background is more in business administration. I have a PhD in information systems, so I'm also interested in the technical side, but I'm mainly focusing in my research and what I'm doing. I'm also editing books on how blockchain or DLT can transform societies and the economy. And you will have all my contact details at the end of the presentation, just in case somebody wants to reach out to me. It's very easy to do so. And I'm really happy that I'm presenting after Ali, because he has made it clear that blockchain technology is not a uniform technology. It consists of many different parts and puzzles, and there's not one particular property that you can assign to it. You always have trade-offs. There is no perfect solution. And I just wanted to make this clear on my first slide. When I'm saying blockchain today in my presentation, I'm referring to all kinds of DLTs with different kinds of implementations. For me, it was just important if companies could use a centralized database to create a solution that has not been created before. And again, my focus was on disaster management, because if you go on the internet, if you search for blockchain, you can find blockchain is a silver bullet for everything. Oh, my slides are moving. Is somebody clicking on my slides. Please, yeah, for some reason my slides are moving forward. I'm not sure why this is the case. Hopefully I can freeze them somehow. So the point here is that you find so many applications, but if you dig deeper, if you reach out to companies, you will find there are not so many solutions around. And I was lucky enough to find 3 companies that already have something in place to have a DLT solution for either natural disaster prevention or recovery in case it has happened. And why is this important? I think that's pretty obvious. So natural disasters are increasing in damage and in occurrence. And one reason for that, of course, is climate change. And here you can see a couple of recent newspaper headlines. But we also have man-made disasters. On the left, you can see the massive explosion in Beirut last year. And on the right side, I have a picture that looks very similar, but that happens 20 years ago in Enschede in the Netherlands. There was an explosion in a fireworks company. So the pictures look similar. And my question is, can a blockchain or DLTs, do they anything to prevent such events in the future? And I found a couple of very interesting solutions. And again, I don't have time to dig into much detail, but there is a paper, and of course, if somebody wants, I can share more information with you. So I reached out to 4 companies, and luckily enough, 3 of them got back to me. So I made a multiple case study. The first company is called Chainyard. That's a blockchain consulting company, and they did a project together with an NGO that's called Miracle Relief Collaboration. So they are especially focusing on floodings. So just in case flooding happens, what can you do, for example, to faster distribute aids to help people? The second case study is from World Vision Nepal. They have a technology unit that's called Sika, and they developed a very interesting blockchain-based solution to help people in case an earthquake has happened. Just imagine you have an earthquake in Nepal, and unfortunately they have those disasters, and then people are cut off, and it's really hard to get them some kind of relief support. And they developed a solution to get them some kind of vouchers, which makes it easier for them later on to get their goods and to make it traceable. And the third example is from a German company that's called MyNXG, and they are experts in security solutions for the industry, and they have developed some kind of private solution. And it's not a typical blockchain, but it's also a distributed ledger. And they are providing solutions for the industry in case they have some kind of, let's say, man-made disasters, to immediately allow access to share information, which kind of goods have been stored and things like that. And so what I did, I had 3 guiding research questions. The first one, why do you use blockchain in the first place? And this is always a question I'm asking companies as a starter. Why do you need blockchain? Why don't you simply use a centralized traditional database? The second question is, how can blockchain help you in either prevent disasters or support with relief after disasters happened? And the third question is, what kind of contingency factors do you have, some kind of external factors that decide on whether a solution is successful or not? And what I did in my research, so I conducted a lot of interviews. I went through the material the companies gave me, and then I was clustering the information I had, and I put it together and I put it in categories. So I found 4 major categories for reasons for deploying blockchain. So the motivation for the companies was kind of different. There was either some kind of social commitment, or another motivation was to just improve performance. In his presentation, Ali has already illustrated how blockchain solutions can be used to increase performance. The second main reason for deploying blockchain is to increase to facilitate collaboration communication. You know, at its core, I'm sorry, the slides are jumping. I'm not sure why this is the case. So what I'm going to do now, I hope you can still see my screen fine. I'm unsharing the presentation, and I'm showing it like that. I hope that you can see it fine.
Yeah.
Okay, thank you. So I don't know why. It seems that there is some kind of timer in there. So the second reason was to exchange information and to collaborate, because at its core, blockchain is a shared database and you have different nodes with different rights, but you can make sure in certain settings that all of the people have access to the same information in real time when they need it. The third cluster for deploying blockchain, the third reason was trust and security. You want to create solutions where you can have trust among the partners, that you're all getting the same information, you're all getting it at that same point of time because you have timestamps, and you want to increase security of the information, making sure that you have some pieces of information that are not going to be shared with some partners, that you can specify in the beginning upfront who gets what. And the fourth reason was about managing it. You know, you can create solutions in the industry to have access control with decentralized databases and things like that to make it easier to determine who is allowed to do what, and also the auditing. And this is also very important for relief companies, because normally they get donations and they have to make it clear how they use the funds. So here we have 4 blocks of reasons, and here we have the blockchain properties. And in the previous presentation, you have seen that they differentiated between properties and the characteristics. I put them together. You know, blockchain solutions, DLD solutions, usually have a couple of very favorable properties, and that's why people are using it. And there is no one single best solution that can do it all. So if you dig deeper, you will see there are always some kind of trade-offs like mentioned before, but on average, what we can do now with these kind of solutions is better than what was possible in the past. So we have a decentralized solution, we have a higher level of availability, we can create data that's more immutable, and so on and so on. And again, auditability, very important for relief corporations, and also issues like anonymity and pseudonymity, because usually if you have a disaster, people are affected in a way, and they might want to keep this information confidential, or even it could be the same with donors. You know, somebody donating money, he or she wants to stay anonymous or pseudonymous in order to keep his information personal. And finally, the contingency factors that I found in order to have a successful implementation could be on a state level. I guess today, later on in discussion, we will hear more about legal situations, but it's very important that you have a legal framework that allows for the solution that you're going to deploy to be legal. And the second one is the individual level. So in other words, people need to be able to use the solutions. What you can see here is a picture actually from Sika, from the solution they deployed in Nepal, that has a very easy to use interface. So the people just needed not even a smartphone, a regular or an old cell phone would be sufficient for them to receive the donations on their phone. And finally, of course, technology needs to be available. If you don't have a landline internet connection, at least you need to have some wireless connection or satellite connection. Otherwise, of course, those solutions will not work. So I put all these factors together in a comprehensive framework, and that's what I'm going to do in my academic research. And of course, in the published research, I'm going into more detail on how blockchain can actually help in the specific cases. In the first case, I already mentioned it, it's about flooding. So you have some kind of flooding disaster, and you have, on the other hand, you have those goods that you need to distribute. How can you do that? Of course, the physical distribution is one thing that cannot be done via blockchain, but at least you can make sure that you have a fair distribution system in place, and after that you have an auditing. The second case about Sika is all about giving poor people access to the donations in a fair way. So if somebody already collected his or her donations, making sure that it's traceable and somebody cannot do this again. And the third case with MyNXG, with the security solutions, it's the same thing. It shared information about what kind of goods or dangerous goods you store where, just in case there is some kind of accident, you can immediately make this information available to all different parties in the supply chain, and you can help security personnel to identify, for example, where people are working and to make sure that nobody's in the danger zone. So I've given you the big picture, and I'm going to stop here. I'm just saying that what I found in my 3 case studies is that blockchain, it might not be a silver bullet, but it can definitely help to create solutions that can do things that were not possible before. So we can create solutions that benefit mankind, or humankind, I have to say, and either help to prevent disasters in the future, especially man-made disaster, or in case a disaster has happened, to have a more effective and efficient relief system. So that was basically my presentation. I hope I stayed within the 10 minutes more or less. Here you can find more contact information. And thank you very much for watching. And if there are any questions, I'm very happy to answer them.
Thank you very much, Horst. Very interesting presentation. Colleagues, if you have questions, you can write them down. Colleague speakers, if you have questions, just, ask. I just would like to ask, first question. Do you think that actually we should probably within several years, right? We should think about global-wide disaster prevention system based on blockchain technology due to the fact that, some, let's say, organizations, they try to speculate, on not confirmed numbers, right? And not confirmed facts and so on. Do you think, is it really the case, for the development of this kind of systems?
Yeah, are you talking about fake news or something like that?
More, similar things, but towards a disaster, happening. Yeah.
I'm not quite sure if I got your question correctly, but the solution I was investigating, they were not really on a global level, but specific. The first one, Chainyard, they have a solution in place for floodings in the United States. Sika was about Nepal, and my NXG has industry solutions. And for their specific use cases, they have all created solutions that were better than what they had before. So I have not investigated any use case, let's say, on a global level where you might have to deal with fake information or information that's not correct. I'm not sure if that would be a great use case for blockchain, because you need oracles to feed information in the blockchain, and every blockchain distributed ledger is only as good as the data you feed into. So I think it stops somewhere when you have to ask about data quality, which was not the case in my 3 case studies that I did, because they were kind of localized, and the data they got was basically correct.
I see. Yes, thank you very much. And probably second question, do you see if there is opportunity? I mean, if those kind of systems, right? They are, let's say, in focus of some specific countries. Countries where you have some natural diseases, right, happening, or it doesn't matter, or it's probably more in the focus on in countries, well-developed countries, for instance, where they can actually invest resources in the development of these kind of systems.
Oh, once you have a solution in place, it's very generic. What they did in Nepal, you can basically use the same solution in any kind of other country where you have a natural disaster. It's just about sharing resources in case something has happened. And I find my NXG a very interesting case, because they basically are developing industry solutions, especially for the chemical industry. But we also had a nice chat, and they told me that they were thinking about developing a solution for skiers in Austria when there is an avalanche coming down. It's the same principle. If you have some kind of disaster in the chemical industry, at the moment the disaster is happening and you have some kind of event, and then you're triggering some kind of responses, and for example, information will be shared. This could be fireworkers. And it's the same principle when you're talking about skiers and you have an avalanche. So the explosion becomes the avalanche, that's the event, and you're releasing information to not the fireworkers, but to some kind of rescue team on the mountain, and they will get information where the skiers are to get them out of the avalanche. So it's very generic. We're talking about patterns here and not about specific use cases. That's the fascinating thing,
I see. And the last one from my side, in terms of, parameters or characteristics of ledger, do you think, for these kind of systems where actually they touch different areas of our life anyway, when we have some disaster happening, right? So different areas anyway under, let's say, strong attention right there. Do you think that probably legislation might be, the, let's say, top parameters there for the distributed ledger, that actually system is legally accepted in specific country and so on? And second, we are talking about some other parameters, or what do you think? Do you agree with that?
Yes, I definitely agree. And I didn't have that much time to go into much detail, but for example, the Sika, they told me that they initially developed a blockchain solution, one system, but then there were legal issues in Nepal and they needed to deploy it on a different kind of platform, but that was relatively easy to do. And my NXG, for example, you can find it on the internet if you Google, or if you search for that, you will find they developed a COVID-19 solution that is privacy, that takes into account the GDPR for privacy, but there were also some political discussions and they never put it to use. So legislation is a very, very important factor, even in cases like that.
Mm-hmm. Thank you. Any questions from the speakers, colleagues? Any questions?
Hi, good afternoon. Maybe I can ask one.
Oh, from the audience. Yes. Okay. Yes. Hello,
Yeah.
Yash. Yes. Mm-hmm.
Hi. Thank you for your presentation. So I just wanted to know, like, I saw the 3 use cases, and they mainly talked about post-disaster solutions, right? And if we want to completely avoid a disaster, okay, fine, natural disaster can be a little difficult. What do you think? How can we do it with the prevent a man-made disaster? Okay, fine, we can have some protocols by deploying smart contracts. So maybe you have some additional information on this.
Yeah, unfortunately, thank you very much for this question. Unfortunately, I didn't have much time to go into much detail, but I had very interesting talks with the companies. And for example, the pictures I showed you about the fireworks explosions, I talked a lot with those guys from my NXG. And just one idea how you can avoid something like that, or like also the explosion in Lebanon. First of all, make sure that many people know what kind of goods are stored where. In Lebanon, it seemed it was some kind of confusion. They had all this dangerous material somewhere. And then you can even have something like a drone or a helicopter going in the sky and from time to time collecting information where something is stored. You can do this wirelessly. You can share this information via blockchain, and then you get notifications if something is getting kind of dangerous. I didn't have the time, but I would imagine in Lebanon, if they would have collected this information that they have, I think it was ammonium nitrate or something like that. If they would have had information given to the right people in time, then somebody would have stood up and said, you cannot store the hundreds of tons of ammonium nitrate in one place, things like that. So you can monitor and share this information. That's a very interesting use case. And again, blockchain is also about data sharing a lot. I've mentioned that. That's how you can prevent disasters.
Thank you very much. Yes, so I think we have time, for the next presentation. So Horst, thank you very much.
Thank you.
For the interesting presentation and interesting topic. So I would like to give the floor to Gilbert Friedgen, full professor in digital financial services, PayPal Pearl Chair, University of Luxembourg. So from Luxembourg. Gilbert, so the floor is yours. We cannot hear you.
Sorry, I forgot to unmute, but you can see my presentation, I guess.
Yes, works perfectly.
Okay, perfect. So thanks first of all for having me in this session. It's very interesting so far. Indeed, I'm from the University of Luxembourg. They're from the SNT, the Interdisciplinary Center for Security, Reliability, and Trust. And we are working on the blockchain topic for, I've been working for a couple of years now. The SNT in itself, I don't want to talk too long about like an introduction, is we are one institute at the university that is very focused also towards collaboration with industry. So really trying to figure out what successful products can make, what can be made with our technologies that we deliver. So we have a couple of projects in different sectors, but I do not want to go too much into detail there. So what I want to start my talk with is an example that you probably all have heard of, is the Ever Given ship, container ship blocking the Suez Canal. So the Suez Canal has been blocked altogether 6 days with 367 vessels waiting, 40 that needed to be rerouted. Each reroute needed 8,000 documents roughly. We had a waiting line of 7 days until everything was cleared, and 1 million joules per second that have been used per ship during that time. So the question is now, you might ask yourself, what does blockchain have to do with this? And there is some quite successful blockchain solution that has been developed by IBM at Maersk. It's called Tradelens. And this solution is there to improve efficiency in container shipping. So when there are trips need to be rerouted, then to exactly forecast the arrival times, real-time recording events so you can plan ahead, and also faster and, for most important, digital processing of documents. What that means, the piles of documents that need to be actually that you need to fly around the world with usual container shipping. So this is the situation that you're currently having. You fly around documents because they need to arrive before the actual containers arrive. The flying around of documents can be prevented because you can process this digitally. So Tradelens is a blockchain solution that is actually being increasingly adopted. But what makes it special and what people tend not to talk about that much is that there is not only one kind of blockchain technology, but that blockchain technologies can be distinguished in different areas. So especially into the dimensions of permissioned and permissionless, or private and public blockchains. And most people always talk about these completely decentralized Bitcoin and Ethereum networks, and talk not so much about permissioned and private blockchain solutions. And Tradelens is one of these permissioned and private blockchain solutions. What does that mean? To be part of the Tradelens, starting differently, to be part of the Bitcoin or Ethereum blockchain, you basically can download a client. You can start running a node, even mining if you want to, mining own Bitcoins or mining own Ether. For such professional solutions like we have with Tradelens, this is different. There you would have usually a private permission system. That means a given consortium of partners who say, okay, we need to coordinate ourselves. We need to do something like managing, sending around documents around the world about the containers that are being shipped. This is a predefined set of predefined consortium of users. Others can join, but it's not open to anyone. So it's not possible that any of you would just say, okay, I want to be part of Tradelens as well. There would be some requirements for you to join this consortium, and you would need to identify yourself, for example. So this means it's not public, it's not available to everyone, and it's permissioned. You need to have your ID, you need to have some identification to join this. But Tradelens is not one, but there's a number of projects that are going on there. So IBM and Food Trust, there's also some initiative that was pushed by IBM, but it's not only IBM that is strong there. There's several others that are working in this topic. Myself, I am involved in activities of two organizations, so not Tradelens, but I've been doing some projects with the Federal Office for Migration and Refugees in Germany, and also with BMW. And BMW, this is what I want to talk about today. BMW obviously had the question, okay, we want to use the blockchain technology for our use cases that we have, for example, within our supply chain, but also like for our cars, when our cars interact with other machines, for example. So we had a discussion with BMW, and they said, well, what is the right technology for our problems? So they found that it might make a huge difference if you want to have a blockchain solutions or distributed ledger solutions, where, for example, you want to manage your supply chain, a little bit similar to what Tradelens does for container shipping, but more like managing the different parties of your supply chain. But it makes a huge difference if you want to build a solution like that, or if you want to build a solution that runs on every BMW. So where basically every BMW is holding a wallet or even a node, running a node for some blockchain, then you obviously need to have a different solution. Also, like questions like the numbers of transactions make some difference there. So we looked into these technologies, and what we did is we developed what we call a distributed ledger performance scan. So this is also now available on GitHub as open source. So we basically try to identify or try to analyze different blockchain technologies according to their technical features. So we wanted to analyze like a couple of quantitative elements, like, for example, latency of transactions or throughput of transactions. How much can a given setup and make in throughput, for example. So we did this. We did a number of analysis to try to figure out what blockchains do have what features, and to do this in a generic way. So it's not only possible with this distributed ledger performance scan. So it's not only possible to analyze a given use case of BMW, but that you can basically define any use case that you want to analyze, and where you want to say, okay, is a given technology capable of running this use case? How did we do that? We did that by developing a framework where we can spawn Amazon Web Services instances that run blockchain nodes of different technologies, and these different technologies are listed there. So we did that in a modular way. That means we can introduce new technologies. So what happens is that we have scripts to automatically spawn Amazon Web Services instances that run a node of a given blockchain, and then we treat this blockchain network that is spawned. We treat this with a number of transactions. So what we do basically is we try to fire in transactions until we see that the network is not able to deal with the transactions anymore. And we can variate these transactions, and we can find out, for example, if a certain technology is able to run a lot of transactions, or if a given technology is able to run larger transactions, so that might carry a higher payload. What, for example, could be possible when you have documents being sent around the world, then you might have a higher payload. A lot of transactions, larger transactions, more complex transactions. What do I mean by that? We have, in many of these technologies, we have the feature of smart contracts. Some smart contracts are easier to calculate, and some are more complex to calculate. So we can test for some technologies, are they able to cope with these complex transactions, or what are the boundaries? How much? What is the throughput? The maximum sustainable throughput of an individual technology. Just to give you a short insight, and this is so obviously you can see you can do a lot of analysis using this. Our vision there is to develop some standardized, like a crash test for a car, to develop some standardized testing where we could say, whenever there's a new version or even a new blockchain technology coming to the market, we can test how well it performs in comparison to what is already there. And just to give you some exemplary result, so what you see here is some experiment that we ran with Hyperledger Fabric. And for example, there you might expect that when you double the performance of each individual node, and you see here on the x-axis, you see the nodes, different nodes that we tested, and they and for them roughly the cost doubles, but the throughput increase is linear or even a little bit below linear. So it's not possible just to increase the performance of your nodes to increase the throughput in the same fashion, but with the doubling of cost, you will have a throughput increase below linear. So you might need to be aware of that when you want to design systems, and this is what we want to look into with our performance scan in the future. So thanks a lot for listening. I'm open to questions, and yeah, I hope you enjoyed my talk.
Thank you very much, Gilbert. Yes, very interesting talk. Can I ask first question? So if your system supports blockchain based on proof of stake approach, or which no, okay.
Basically, no. It's not. It's not. It does not matter to us. So basically, we are focusing here on private blockchain solutions. So if we test Ethereum, this is about the private Ethereum network. This is not about the public Ethereum. So maybe this is important to mention. And for private Ethereum networks, you can also, I mean, what we can also vary is different consensus mechanisms. So some blockchains also give you the option to choose which consensus mechanism you want to apply. And what we can do is switch this easily and thus check which consensus mechanism might be more useful for a given case, with the pros and cons that every mechanism obviously has. So some might have a better performance, but a little bit less security or something like that. And then you need to be to make an educated decision about what fits your requirements best.
Okay, and another question. So I'm wondering, in terms of performance analysis, have you analyzed how long does it take, when actually a system records their blocks, to the hard drives, somewhere to the database, right? If it's, let's say, the weakest point for the distributed ledger, or it will be the weakest point, in the future, because it's not that, fast enough as, other, let's say, part of the system.
At the moment, we did not see any restrictions in the hard drive topics. I mean, so this is at the moment not the strongest focus of our work. So what we did is to do some testing also with Amazon Web Services instances around the world. So we wanted to simulate basically a ping time also. So how much does network latency play a role? We're not focusing on the hardware, on the end hardware, obviously, as we're doing this in Amazon Web Services at the moment.
I see. Yeah, thank you very much. Colleagues, if there are any questions from the speakers, from the audience?
Maybe I can ask one question.
Yes.
Thank you for your presentation again. As I understood, you have used Hyperledger Fabric, right, for your model?
We can do it on a number of different blockchains, actually. So so this is a selection that we have currently implemented, and that we can currently benchmark.
Okay, no, because I just thought you have implied in using Hyperledger Fabric, and I thought if they use the BFT, so I just wanted to know if you have used this scenario where if some nodes fail to validate this.
Yeah. So we have also scenarios where we say, okay, what happens when different nodes drop out during the experiment? So this is we were building a framework that you can use to test different scenarios, basically to put pressure onto any technology and to see how well it can cope with it. So that's the idea, and thus to be sure to make the right decisions when you go for a certain technology for a given use case, to make sure that you're using the right that you know what you're using. Yeah.
Thank you.
Thank you very much. Yes, I think if there are no questions, so I guess we should go with the next, let's say, short presentation, because at the end we will probably take additional time for the discussion, I guess. So I would like to give the floor to Mikhail Loginov, Business Development Programs Manager from SAP CIS Russia. So Mikhail, the floor is yours.
Thank you, Mikhail. Can you hear me? Can you see my screen?
Yes.
Let me start with the first slide. So yes, I'm part of the SAP CIS team who's responsible for working with the financial service industry, including commercial banking, insurance company, and central banks. And just to when I trying to understand what is the best case to present during this presentation, I checked several cases in public sector, for example, when the blockchain is helping with fighting bureaucracy, in utilities with energy exchanging scenario, HR, and so on. But finally, I decided to stay with DLT in RTGS payments. RTGS, it's a real-time gross settlement system. It's a cross-country system which is usually owned by central bank, who dealing with mass bulk payments from bank to bank, from person to person, from company to company, and so on. So it's a high volume business, and it's I found out that it's a very interesting example of proof of concept and using DLT for. I think it's quite unusual from my point of view case because of the volume of data and volume of transactions. What it's what is the topic? What's the motivation for this demo case? Sorry, my echo. Today payment system are being challenged by new options provided by blockchain technology. I think we can hear about digital currency and planet digital currency. Central banks are entitled to emit the national currency and responsible to guarantee the working and the stability of the financial system of country. And we decided to be part of this progress and prepared together with Accenture and R3 this prototype. So what is the prototype is about? The goal is to make a showcase as a first step to the future horizontal and vertical interoperability of payment system, existing payment system, and DLT using SAP technologies and R3 Corda. So it's as an example, we took 2 DLT-enabled commercial banks, 2 conventional banks, no DLT commercial bank, and 1 central bank. And the process was following: commercial RTGS interbank payments issued some order, and this money will transfer from with different passes. I will show it a little bit later. And what we were using and are using for the system is the SAP core banking system for commercial accounting, for commercial payment processing, plus R3 DLT system with nodes for commercial and central banks. The reason we decided to go with Corda is performance. It's currently it's proven we can reach 6,300 transactions per second using DLT technology by R3 Corda. So it can, how to say, prove future ability to cope with such kind of mass data. Yeah. And then another point is that Corda was built by financial institutions and for financial institutions. And this is important that from observer, from transparency to regulators, the observer node of Corda, which is really only nodes, were designed with the regulation in mind in order to enable oversight and monitoring. It's important because, you know, central banks would like to keep control on all money transfers in country and cross countries. What we really did, it's a concept. It's a concept built in real system. We have special environment to run the system, and showcases showing how we can use tokenization of money transfer. So showcase is the first step of the future of horizontal and vertical and interoperability of payment system and DLT. So it's we show how easy it can be integrated new distributed technology RTGS into existing RTGS, and how can money transfer from old fiat area to the new digital currency area. What is the scenario? The main part of the scenario is DDR. DDR is a digital depository of receipt, and it's a token issued by central bank and controlled by central bank. DDR represent a claim on the central bank, and it's tokenized actual reserve. So it's reflect real money that commercial bank has on a reserve account in central bank. By paying DDR tokens, it means that reserve of a commercial bank holding by central bank are decreasing or increasing, and banks can only buy tokens if they have sufficient reserve in the central bank. So we are not talking about cryptocurrency, it's just about tokenization. And what is about scenario? The cycle starts with a participating bank who requests token purchase at the central bank. So it's a real purchasing process. The central bank responds by debiting the participant reserve account and issued a digital repository receipt token. And token can be transferred and will be between participants or may be returned to the central banks. And so it's redemption mirrors issuance, redeem the token, the participant's reserve account is credited. So in this scenario, we can several passes of the money transfer, for example, from digital depository receipt to conventional money and back. And what is important is that technically it's not a problem to exchange the digital depository receipt between banks and avoiding any noticing of central bank, but we decided to let central bank know aware about this transaction because of the central bank expect transparency of this process. This is scenario, and from technical point of view, it's combination of core nodes for the transferring token, for accounting token, SIP solution named payment adapter. It's actually is a payment engine and core banking who are responsible for holding account information and responsible for routing of payments, because for SIP payment engine, DDR is just another currency. And from technical point of view, it's not big difference between conventional money and digital money. And this scenario was built by our partner Accenture, and at the moment we are discussing with several central banks if they are interested in this scenario. And as far as I know, some of the central bank in some countries are involved in future steps in this scenario. What is our key takeaways? So DLT is really becoming the mainstream. It's a fact. We have many examples of using DLT and DLT for payments and trade settlements, and so it's not possible to say it's a proven solution, but it's a right way and right direction. The transition of DLT is a key issue. we have many questions open, and how to manage the transition from existing RTGS models to DLT enablement. We show it in our case, but it's still subject to discuss with authorities. So, and what is important, DLT not replacing RTGS. DLT is a way to transition to be complementary to a real time gross settlement system, because it's not possible to switch on at the moment payment system in any countries. So the concept already works. We can show it in the physical level, in the user interface, in recordings. And Accenture, R3, and SAP jointly created this proof of concept and can demonstrate it on request. And so central banks are firmly in the driving seat. So it depends on the central banks how can we proceed in the future. Central bank can have the best of both worlds using this technology, and this example is just another another demonstration of this process. So it's my short overview. I trying to be short as I can. One thing I should mention, SAP started many years ago in 1972 as a general ledger company. Maybe you know, it's a ERP, it's a centralized general ledger system. And evolution from centralized general ledger to distributed one is very interesting for us. So that is why we are trying to use this technology as a source for our future development. So thank you so much for your attention, and thank you so much for having me.
Thank you very much, Mikhail. Mikhail, I will leave discussion, for let's say 7 minutes later a bit. So I would like to give the floor to Alexei Tsvetkov, because he has to run afterwards to some competition, I think. And so then we will continue discussion on the fintech area, if you don't mind.
Of course. Yeah.
Thank you. So Alexei, the floor is yours. Alexei is the head of software development at FinTech Association of Russia.
Thank you, Mikhail. Thank you, colleagues. I'm glad to welcome the audience. First, I would like to introduce FinTech Association. We are the consortium of major Russian financial market players. We work in topical groups to develop technical solutions and legal approaches toward innovation in finance. One of our production-grade projects is MasterChain. It is the blockchain platform certified by the Russian government. MasterChain is now used for mortgage accounting and for trade finance services by largest Russian banks. Looking at how can market parties communicate in a secure technical setting, we arrive at the public key infrastructure being the traditional solution. So it's the solution which enables security management between applications integrated in such a multi-party setting. MasterChain platform has the Russian PKI standard fully integrated. We implemented the solutions for centralization problem of the PKI so that multiple parties must somehow receive public key information from one central authority. And also we implemented the solution for the requirements on periodic rotation of cryptographic keys so that cryptographic keys can just be seamlessly changed and that would not affect some business processes and business logic implemented in the blockchain platform. Our solution is based on system smart contracts. These contracts store public key information. They identify network users, identify nodes, and identify content entities on the platform. And the smart contract code is used to validate access requests, which are made by users. so that all of these functions are available to application contract developers, so they can somehow abstract from the processes of key management and abstract from the processes of controlling integrity and authorship of attachments they are dealing with. I should also introduce the confidential messaging system, which is an extension of the original Ethereum protocol that we implemented, and it allows all the messages to be signed and verified by authorized certificates. And message sharing is controlled by the role model defined in smart contracts on the platform. Next, I would like to give some example of role model rules. You can, for example, authorize some users which have the function of managers in the organization which has the role of a mortgage custodian for some special mortgage security entity. And so here's the rule that allows such managers to receive information about mortgage securities and even the signed XML documents and read their content. Also, you can make such a rule in the role model that would allow the accountant of the guarantor bank to upload some draft documents, but he would not have the right to issue the letter of guarantee. All of this information is shared between all the participants in the network by means of smart contracts. So I think for the conclusion of my very, very short talk, I would like to say that production-grade financial applications can use DLT to deliver public key information. Also, the point of the system, of the technology, is that smart contracts, which are implemented in the blockchain, can be the basis of application security logic, which can be then extended, modified, and I think that the most important point is that logic is verified by all the parties in the ecosystem, so they can just go on, implement and grow on some business logic, but not to mingle with the mechanisms for security of the applications. So thank you for the attention. If there are some questions, I would be glad to answer, or maybe that could be in the following section.
Thank you very much, Alexei. So colleagues, if there are any questions, because I know that Alexei should run to the competition, to the jury. So if there are any questions to Alexei, so please ask. Because if no, then if there are any questions, colleagues, then probably I will ask a very short question, Alexei, and then so the question from my side, do you think that if you consider, DLT and parameters of DLT, right? So that number one for the fintech area in general, it's a legislation, and number two, the security and performance and some other things, they're going somewhere afterwards. Do you agree with that? Or?
Thank you. Yes, that's a very good question. Well, performance is, of course, one of the major goals and major characteristics we actually look at when just examining some platforms, some open platforms, protocol standards. But I think that that is a technical question. Like we could first find some means to integrate blockchain in the actual business processes, in the actual, some legislation rules, and then the development of technical solutions would allow us to achieve some more performance that is critical.
Mm-hmm. Thank you very much, colleagues. If you have any other questions. So if no, then thank you, Alexei. Yes, and I would like to slightly come back to the previous presentation and also ask the same question actually to Mikhail. So Mikhail, do you agree that, for solutions, for the banks, right, if we consider, parameters, right, of distributed ledger, we think that, the most important one, it's a legal aspect, so that it's legalized, right, in the country where you're implementing the solution. Second is the security, because especially if you're talking about those tokens for the central banks, right, so the level of security should be probably, higher than we are talking about, some other applications, right? And afterwards, we are talking about, performance and some other parameters of the distributed ledger. Do you agree with that, or?
Yeah. It's absolutely correct. But I think every participant, every party are doing their own work. So central bank and trying to push correct legal requirements, and at the same time, for example, master chain is a great example of moving in this direction. At the same time, technology companies like Accenture, SIP are trying to do their best to provide ready-to-use technology for future movement. And of course, we are jointly working on the same tasks, but from different sides.
Mm-hmm. I see. Colleagues, any questions to the Mikhail's talk, to the case with central banks and tokenization, I think, right, of let's say central bank activities. Is there any questions from the speakers, from the audience? So if no, then we will continue with the next speaker. So who will tell us, how correct we are in terms of actual legislation and approaches, right, which allow us to, let's say, to implement solutions. I'm very happy to give the floor to Thomas Nägele, so attorney at law, managing partner of Nägele Attorneys at Law from Liechtenstein. So Thomas, the floor is yours. Let me just switch your mic. I think your mic. We cannot hear you. I think.
Yes, I didn't talk. Sorry.
Oh yeah. Okay.
Good. For final go.
Yes, the floor is yours. Yeah. Thank you.
Perfect. Okay. Thank you very much, first of all, for having me and allowing me to talk about the legal framework for the token economy. Actually, I really enjoyed the talk so far. Normally, I'm used to be in panels with a lot more regulatory, central bank representatives, and a lot of other lawyers. I will not bore you with my CV, but I used to code software also a little bit, so I have a little bit of a technical background, but I actually consider myself to be a horrible coder, but for a lawyer, I'm quite okay. But what I really liked about the talk is that we started with Ali, and Ali illustrated perfectly well that it's not the case that there's the DLT solution or the kind of blockchain. It's a very comprehensive topic, and there are a lot of implementations and there are a lot of solutions. And then Horst briefly touched also on the requirements for a proper legal framework. So thank you very much for having me. I will switch now my system to the presentation mode, and I will talk a little bit about the legal requirements and how you can actually, or what is one solution, how to address the needed amendments for a legal framework to serve as the basement for the token economy from a legal perspective, and how we did it in Liechtenstein. And we have 10 minutes, so I'll try my best to keep it as short as possible. As a lawyer, this is not legal advice. I will not touch on my CV. As I said, it was a part, I used to code software, but what is also interesting is that it was a part of the work group of the Liechtenstein government writing exactly this piece of legislation. So for the last years, I was quite heavily involved in this area, and which allowed me and was a lot of fun for me. Liechtenstein started in 2016 with the idea of regulation, and the idea in the beginning was maybe it's not necessary to have a specific piece of legislation. So that could be one solution, that we don't have a specific piece of legislation. So first we answered the question if we should just leave it as it is and don't regulate it specifically, or start with an own piece of legislation. And Liechtenstein answered that with an own piece of legislation, which is in force since 1st of January 2020. It's called Blockchain Act, or TVTG. And what is interesting, and I think we already touched on that a little bit, is that the Liechtenstein Blockchain Act is not talking about blockchain or DLT. So we're not categorizing or something like that. We said what is really innovative about all of these technologies and these new solutions we have here. And the interesting part is that people or persons or individuals are able to interact with each other without the necessity to trust each other. Plus, they don't need an intermediary. I mean, in the past, we have a lot of regulation, and one of the key reasons why we needed this regulation is because we had intermediaries, and the clients of these intermediaries had to trust them, and that's how you build up trust. And Liechtenstein said no. Now there's this new innovative technology, which is called DLT, blockchain whatsoever. But in the core, the idea is that it is providing a technical solution to transfer value without intermediaries. So that's why we refer to the trusted technologies. What we also didn't do is we didn't classify tokens. So whatever token that is, if it is treated as a security, utility, or currency, at least in the act itself, doesn't matter. From a supervisory part of view, yes, our Financial Market Authority also differentiates between securities and utilities and currencies. We also heard a very interesting talk about CBDCs. But we said for what this act was actually for, it's not needed to have a classification. We ended up with what's in the core of this new technology, and in the core is that as I said, you have the ability to interact without having intermediaries. So we said, okay, if we have now this big picture of a token economy, and what do I understand when I talk about the token economy? I mean, there's no universally accepted definition of a token economy, but the idea is actually to have a lot of assets which we don't have now reflected in the actually being able to transfer them to a digital representative. We can now actually let a token represent whatever assets we have in the real world. So be it, for example, a physical object or an IP right or whatsoever. And all of these newly tokens actually created that's called actually tokenization, build the token economy. Plus all of the services which were actually will be developed, and maybe also new services and products will be developed with this newly now tradable and easily transferable digital assets. And so we said, okay, what do we have to do? And where do we have to amend our legal framework? The idea was really to think about everything. So not only covering one part, supervisory part, for example, that if we all heard about the ICO craziness in 2017 and 18, where people were raising a lot of money, and we had to protect investors. That's only one part of it. The idea was really to have analyzing the whole legal framework and say, okay, now at the civil law, we have to amend this and that, corporate act, we have to amend this and that. And then we ended up with, in the center, what we need is a definition of a token. So that's our definition of a token. We say a token is just a piece of information on a TT system where, and now we have a lot of technical, very advanced speakers here, which took us actually more than a year to think of as neutral definition from a legal point of view of a token as we have it now, to be as agnostic and technologically neutral for all of the developments will hopefully we will see in the future, but that our legal framework will be able to cover them. So we said token is nothing else than a piece of information. It doesn't matter, and we touched we did deep dives on Bitcoin, Ethereum, and permissioned blockchains and how they are actually working. So we said, okay, we have to catch them all, and said, like, what's a universal approach? And the universal approach we found was actually define it as a piece of information on a TT system, trusted technology systems, which can represent actually rights and is assigned to one or more TT identifiers. I will not touch into much detail there. So the concept in general is that you actually have a token, you define it from a legal point of view, from a technical point of view, with functions, what the tokens can do, what they cannot do, what are the oracles and everything from a technological point of view. And I always use this picture with the braces here, and I say, okay, now you have the token, which is nothing else than a digital container for the right. And then you have an asset, so for example, a diamond, and how can you do from a legal point of view, like this tokenization, how this really works. What you do is you define a right, or you can even define multiple rights. So for example, you define the ownership right for that physical object. Let's say ownership, which is a good example. You define the right, and then you actually let a token represent that right. That's tokenization. Now you have a token representing the ownership right of a diamond. The good thing here is you can use whatever DLT or blockchain system to easily transfer it, to have whatever sophisticated solution, multi-signature, auto, smart contracts, whatever. And on top of that, you get the legal certainty that if you transfer the token, your ownership right is also transferred. We also said then, okay, for specific use cases, you will need, again, new intermediaries, which one of them is a physical validator, building the bridge between the real world and the digital world when it comes to physical objects. That's one other solution here. And this token container model actually results in a very flexible solution for tokenization of rights, for physical objects, but also for any kind of assets, utilities, IP rights, securities. So we amended, for example, also our corporate act. It's possible to fully digitally found your corporate in Liechtenstein and issue fully digital securities from day one with the use of tokens. And you might ask, okay, but what's that all good for? Because in the end, I mean, the technology anyway works, you know? I mean, if I transfer a token, it is transferred. I mean, I cannot actually do nothing about it, you know? But as we all know, first of all, things can go wrong, even with technology. And secondly, the problem is that if you try to have this universal approach and you have this token economy in your mind and you want to tokenize things, the problem is that only with the trusted technologies, stands for DLT blockchain again, the problem is you don't have the enforceability. So you need that legal framework that the real world asset actually is transferred as well. And if something goes wrong, so for example, if I tokenize a physical object, represent that right in a token, transfer that to Mikhail, for example, the token. If I don't hand over the physical object, he has to have a claim, ask the court to help me. And that's why we need that legal certainty if something goes wrong. And that was the idea actually of the Blockchain Act. To put that on one page and have 1 minute left, on one page, what's the act is all about? It's a almost 60 pages act with 350 pages of material, so it's a quite comprehensive piece of legislation. But on one page, we have in the center the token definition, just a piece of information on a blockchain system which can represent rights. You have functions of tokens, we'll not touch on that, legitimization, liberation, and transportation. Securities experts will understand these three functions pretty well. We have a relationship model, so we're not talking about private keys or public keys. We have a way of identifying individuals, and we have a way of how actually these individuals control the token. That's what we call relationship model between identifier and TT keys. And if you dispose over a token, that's the interesting part, you also dispose over the right. You transfer a token representing ownership, you also transfer the ownership right. And this will allow you to tokenize a quite broad, like a very broad new asset class, or you can even define a lot of new assets here, which are at the moment not tradable because it's very hard to digitize them. And how we do that? With a model of representation of rights. You have an asset, define a right, and this asset is this right is then represented in a token. We didn't cover the service providers, which is another topic, and we get that legal certainty because we have this fully fledged and well thought through, I think, a piece of legislation, which was now also actually, by the way, parts of it are now reflected in the European Commission piece of legislation, which is a draft MiCA as well. So some basic concepts here as well. So key takeaways are trusted technologies, not blockchain DLT, which is, it's not bad or good, but from a legal perspective, you have to have a technologically neutral approach. There might be other solutions. The token container model, which was representing rights in a token. And third, legal certainty, which we all need. If we want to use the technology, you have to have enforceable rights. So you need that legal certainty to actually allow this token economy to flourish. Could serve as a blueprint for others. I actually am only 1 minute late. Thank you very much.
Thank you very much, Thomas, for very interesting presentation. I still don't know how you got this, opportunity to present with the video at the same time. Anyway, it's interesting trick for the lawyer. But in general, I have one question. Do you think, that this approach is scalable? I mean that, to the other countries. And again, which countries do you think might adopt, this legislation? Or we are talking about, it just depends, right? So if they really have strong wish, right? So it doesn't matter which country we are talking about.
You're afraid of the lawyer's answers. It depends. I will not give you that answer. No, actually the approach was, and I think that's the approach. The approach is to build up knowledge first. And in a lot of panels, presentations, talks with regulators, I always try to do the same. Educate them first. Because what we see now is with every new buzzword, with every new technology, now it's DeFi, now it's CBDC. The problem is if they don't understand what's really happening there, if they don't understand the technology, the problem is we'll not be able to find good solutions. And the Liechtenstein approach was build up knowledge first. It took us 1.5 years to build up the knowledge and then analyze the local legal framework, had the vision of the token economy, and just did what was necessary. So I think that approach is universal because you can do that in every country. In Russia, you will do the same. Understand the technology, have a vision, what's the idea behind it, and then just do what is needed, But I think you cannot get over this build and knowledge part because this will not going to work. And we see that now in a lot of discussions. DeFi is one of my perfect example, or for example, like decentralized exchanges, I mean, if you really look under the hood, and understand it, there are really very clever solutions. And I think the European Commission did a quite good job there as well, for example. But it takes time. It's not an easy job, but I think it's a very, very interesting job. And I think these new technologies really deserve a proper legal framework. Don't stop innovation because you're afraid of it, because you're afraid of spending time understanding it. That's my vote for that.
Thank you very much. Any questions? Yes, from the speakers?
Yeah, actually, if I may, first of all, thank you very much, Thomas. You really made it crystal clear. But I have a question that's really at the bottom of my heart because I don't really get it. You made it clear how it's possible to tokenize an asset and then transfer the rights. It's clear for me when it comes to real-world assets. But when we're talking about digital assets, now there's the huge hype around NFTs, non-fungible tokens. I would say there's always a risk that somebody who has the original later makes a copy. And even if that might be illegal, do you think that's going to happen a lot in the future? Somebody has a digital asset, transfers the rights, but he or she has the original and then just spread it later on.
I think one of the key aspects of these technologies is that you can have unique digital data in a way. And I mean, from a technological point of view, and there are much more technological experts than I am, so please correct me if I'm wrong. But from a technological point of view, a digital rights management is nothing new. If you want to, you can do that, I mean, the overall hype about NFTs, I mean, come on, NFTs are nothing new, you know? But now just an NFT is worth 60 million. It's a 20-piece line code, nothing else. Come on. But like, that's what I was talking about. I think from a legal perspective, that's pretty simple. I mean, you define a set of rights, you know, and if somebody doesn't have the right to use your IP, or you issue a license and he's not dealing with it properly, yes, you might have claims against him, you know. But I think, like, when it comes to you need that legislation when it comes to the bridge with the real world. That's actually the heavy lift here, you know. With the digital assets, it's actually quite easy. If you transfer a digital asset, it is already transferred, you know. I mean, in very low occasions, you might have problems with it where something goes wrong or whatever, you know. So I think that's not the real deal here, but I totally agree. I mean, we will end up with having a lot more digital assets than we have now. In general, and the devil is always in the detail, you know. Like, we learn every day now. Like, we have this act in force since 1 year and 4 months, you know, and we learn every day. And like, we try to tokenize piece of art, you know, like real piece of art, and you have a friction of piece of art. And then the question is, if you define a license that you can show this piece of art on specific times on your digital TV, for example, you know, you have a combination of both, you know. These are the interesting areas, I think. But thank you very much. It's a very, very good question.
Next,
Thank
Ali,
you.
please. Yes, thank you, Horst. And then Denise. Yes, Ali, please.
Thank you, Thomas. Thank you very much. I actually think that this token container model from Liechtenstein is quite beautiful. But I have to ask the question you probably heard thousands of times. But I just wanted to hear your take on this. So what happens with the rights to kind of have the access to this token, and the idea coming from the General Data Protection Regulation with the right to be forgotten, that, you know, because it's kind of, you know, the rights are still traceable and there is still kind of some temporal resistance. So how is this core idea actually in contradiction to this, you know, even what we kind of said like 3 or 4 years ago about blockchain, about all this immutability stuff?
I think it depends how you implement it. So, for example, if you tokenize, let's say, the ownership right of a physical object, you know, what you actually do is, for example, one solution could be that you define the serial number of the physical object plus like the EAN, and then combine these two numbers, hash it, and put a tokenization clause, that's what I call it, on the physical object, you know, and then just use a token. You can use like the token ID or token URI, and then define in that token the token URI. So, and if you want to have like no problem with GDPR, hash it first, you know. I mean, and then nobody can actually make use of this information, which kind of model it was, which kind of what you were transferring. But yes, I totally agree. Like, this problem with GDPR is a problem, and in the beginning, and here it is the same. Like, yes, if you do it wrong, you might have really serious problems. If you write in a public ledger transaction, private data, which you will never be able to erase, you know, yes, you might have serious problems, you know. But if you think of using these technologies, I mean, you have to not only, like, you have to think about GDPR, you have to think about securities law. I mean, it's really, from a regulatory point of view and from a legal point of view, it's a very interesting field, but it's a really highly complex and almost everyday evolving situation, you know. And I think GDPR is actually something where blockchain could bring very good solutions. For example, when you talk about identity, you know, I can use this technology to minimize the data I'm using. So if I want to buy a cigarette, we have one actually role in our TVTG where we say, if you want to have if you want to know if someone is allowed to buy cigarettes, you don't know, you don't have to know his name, his date of birth, his place of birth, because what is happening is normally you ask him to show his ID, but there is a lot more information that the other party is needed. What you can do is you define a service provider, you get identified once at the service provider, and the merchant is only asking, is this, for example, identifier allowed to buy cigarettes? In other hands, are you over 18 or 16 or whatsoever? And the question is, the answer is yes or no.
Yeah, but you know, it can be protocol that somebody kind of requested that you are actually over 18 or whatever. And so, yeah, but I got it. And I think
I think like, yes, the question is a very good one, but the problem is which data is really stored, or the question is which data is really stored. You know, it will be an identifier, whatever address they were interacting, you know, like you have the transaction, you will be never been able to delete it, you know. And if you are not, if you implement it in a way that you always use the same address, like when we started to accept cryptocurrencies as means of payments, you know, like people were asking why we do such, I mean, back then it was really hard to always use a new address, you know, and like, because otherwise, every of our clients would be able to see that all of the other clients, or at least the addresses, were transferring which amount on our address. You know, I know it's with blockchain analytics, you can do a lot. You know, we are not talking about anonymity. It's actually not the point. You know, but we also know that there are implementations where we really, with blockchain analytics, you can do almost nothing. You know, ask like the law enforcement guys. They have a heart attack when they talk about Monero, for example.
So, Denise, you're the next one. Just let me conclude that we really
thank
need
you very much.
we really need you guys. So, law school and law guys, we need you. Please stand with us and go hand in hand with us, okay?
Thank you, Ali. No, we already agreed with Denise that he will ask after his presentation, because Denise will cover DeFi as well and some other topics, so I think it will be interesting. But now I would like to give the floor to Konstantin Vishnevsky, who is a director of Central for Digital Economy Studies at the Higher School of Economics, with very interesting talk about blockchain in Russia.
Good afternoon, dear colleagues. My name is Konstantin Vishnevsky, and during my speech, I will provide a brief review of the state of the art and future prospects for blockchain in Russia. The basis for this review, it's a number of projects for the Russian Ministry of Digital Development, some big Russian technological companies, some banks, also a series of different organizations, both IT companies and industrial enterprises, and of course direct work with the most relevant experts in Russia. And I would like to say thank you very much to Mikhail Komarov for his active participation in many of our expert procedures. So one of the major source for our studies is using intellectual big data analysis. So we developed our own system called I4A, and now it covers more than 400 million documents, scientific publications, patents, grants, market analytics, and many other sources. So it gives us an opportunity to make a mapping of different areas, because of course we are not the very deep experts in all of the areas of S&T development, but this system gives us an opportunity to make this mapping very fast and try to reveal the major trends and aspects. So according to this analysis, we can conclude that blockchain technologies is one of the leading digital technologies now. So mapping of distributed ledger technologies can show us that it is not only a blockchain. Of course, we could find here a number of decentralized applications, smart contracts, consensus algorithms, proof of stake, and many other issues. So analysis of trends show us that, of course, one of the most stable trends for the recent years. It's using of cryptocurrencies, also like central banks using all these digital currencies, but also among some dynamic trends, such issues like open source code, blockchain, different types of decentralized services and exchanges that we should also take into account these trends. And the next source for our analysis, it's a deep research of scientific publications and patents. So according to the analysis of scientific publications, we can conclude that blockchain now is one of the real leaders. So Russia now, it's the seventh place in the world in terms of scientific publications for blockchain. And here we could find some leading universities, three universities from St. Petersburg, and also the Higher School of Economics that contribute also to this seventh place for blockchain. The role of Russia in terms of patenting is more niche, so we are only the 18th position in terms of patent activity. So I mean not all of the patents, but only international patents. So we analyzed the wiper patents for this study, but in contrary, our place is not so good as in scientific publications, only 18th, but the trend is also positive. For example, several years ago, our place was not so good. The major actors in patenting, it's big Russian companies like Kaspersky, Yandex, and also Abby. So let's discuss now the blockchain applications. So as we consider the global agenda for applications of blockchain technologies in different economic sectors, we can conclude that one of the most promising application, it's not only for example, healthcare applications, some storage of medical information and genomic data. Also, one of the most promising areas, it's industrial applications. And last year, we made a survey of Russian organizations. So it was about 1,800 different organizations, including 1,000 organizations from industry. And so we asked them about what kind of technologies are the most relevant for them now, what kind of technology they are used now, and what kind of technology they are planning to use, for example, in 5 years. And we can conclude that right now the level of using blockchain technologies in Russian enterprises is relatively low, for example, comparing with the world dynamics. But the trend is also very positive. Our companies are expecting that, for example, in 5 years, the blockchain using in different enterprises will increase significantly, both in terms of demand side from these enterprises and from supply side, using the data, for example, from IT companies. And at the end of the last year, we also asked leading Russian experts about the influence of COVID-19 on different types of digital technologies. So we could see here that the pandemic provides rather a contradictory influence on blockchain. We could observe the increased demand, but also a possible slowdown in some areas. For example, we could definitely can expect the increase in the supply of technologies for organizing and synchronizing data, and technologies for creating and executing decentralized applications and smart contracts. But also there are some areas that may can suffer a bit from this deterioration of demand. And the last but not the least issue that I want to cover today is the fact that Russian companies now are really actively thinking about blockchain applications. For example, even 3 years ago, we built a technology roadmap for one of the leading Russian company. And this roadmap covers the whole chain, starting from algorithms and blockchain network design up to market prospects and effects for different areas. So this company that now could be positioned like a technology giant of the Russian economy, use this technology roadmap, first of all, to challenge existing beliefs of developers, also to help their decision makers to make such decisions about financing of those applications or initiatives, and even for potential mergers and acquisition deals. So that's why we can conclude that prospects for blockchain in Russia are rather bright. And that's all that I wanted to say. Thank you very much for your attention. If you have any questions, I'll be happy to answer them.
Thank you very much. Yes, colleagues, please, if you have any questions, so please ask from the speakers. I can ask probably, one question, Konstantin, so do you think what are the challenges for the Russian companies in terms of implementation, distributed ledger technology, whether it's cost of infrastructure, whether it's added value, which they receive, because I'm sure they have some other challenges, right, in Russia, or some other reasons?
Yeah, so I think that the major barrier for us, it's a relatively low digital literacy, both in terms of humans and for companies. So it's not only about blockchain, it's also can be positioned, for example, for quantum technologies. And everyone now is waiting for different breakthroughs from artificial intelligence. But we definitely should to increase this level of awareness of potential applications of blockchain. So it's not only cryptocurrencies, it's not only Bitcoin. So there are a lot of different potential effects. For example, reducing of cost for transaction, reduction of operational and financial risks. And so we need to increase this level of awareness for our companies.
Thank you very much. Colleagues, any other questions to Konstantin from your side? So it's very clear, because I think it was very interesting presentation showing the overview, the landscape, right, of Russia and blockchain here in Russia. So, okay, thank you very much, Konstantin, for the great presentation. And now the last small talk. Sorry, colleagues, here we almost, we are already 30 minutes, late than expected, but we still have some time, so that's great. And I'm sure that recording of this, roundtable will be extremely interesting for the audience when it will be placed on YouTube. So I would like to invite Denis Smirnov, so co-founder of One IDAO project, consultant from Sonoma, crypto blockchain system, right, and representative of the platform LISC, and they also invited lecturers at the Department of Business Informatics, Graduate School of Business, HSC. So Denis, the floor is yours.
Thank you, Michael. Well, hello. My name is Dennis. I've been in the cryptocurrency industry for over 6 years for now. So I managed to be a trader, an investor, developer, but mainly now I'm a researcher and analyst in the field of decentralized technology, mainly in the field of decentralized finance and decentralized autonomous organization. Long story short, we'll talk about the problems with the implementation of the DLT and the ways how to overcome them. So basically, the advantages of the distributed ledger technology in the areas where it can be applied are quite obvious. It allows us to solve one of the fundamental problems associated with the human interaction, the problem of trust. Thereby revolutionizing some familiar areas of interacting by just optimizing them. But with any technological revolution, there are also problems of adapting already formed systems to some new processes. And the implementation of DLT also carries a number of potential complexities, which I will give a very brief overview. But nevertheless, it's worth clarifying that almost all of them can be attributed not to critical problems, but let's say it's a growth disease that will eventually be or maybe already overcome. So in general, the difficulties for the widespread integration of technology can be divided into two large parts. The internal problems, which are due to the very specific of the technology itself, and the external ones, due to the situation in the industry. And let's talk first about the internal ones. And the main internal problem of the distributed ledger technology, especially blockchain, is the problem of scaling. For example, the Bitcoin, the most famous application of the distributed ledger, is built on the proof of work consensus algorithm, which is one hand very effectively ensures the security of the entire network, since changing the information will require an incredible amount of computing power. But on the other hand, such approach is incredibly energy consumption, and today the Bitcoin network consumes about the same amount of electricity as a small European country, and over time, energy consumption will only increase. However, this problem is now effectively solved in other distributed platforms where alternative consensus algorithms are used, such as proof of stake, delegated proof of stake, proof of authority, and many others. And their use allows us to preserve all the advantages of the technology without requiring significant energy costs. Also, another aspect of the scaling problem is the actual size of the blockchain. Since the blockchain on distributed and any distributed ledger is basically a distributed database that stores the information about all the transaction, and it is stored simultaneously on all the devices of all network participants. Therefore, the problem of the size of the blockchain is quite acute. And today, the full node of the Bitcoin occupies dozens, and the full node of Ethereum hundreds of gigabytes, which is very detrimental to the decentralization of the network. However, there is a lot of research in the technologies of sharding and as well as level 2 solutions, which allow us to hope that in quite a near future, there will be an effective solution for this problem. The second major internal problem of the decentralized ledger is so-called the problem of oracles. We can trust the information that is already in a blockchain because we know that no third party ever had the opportunity to make change to it. But when it comes to placing any information from the real world in the blockchain, there is always a question of trust to the one who provides this information. And basically, the problem of oracles today is one of the fundamental problems of the technology, but various solutions built on decentralized network of oracles, and which are using the elements of economic motivation and game theory to coordinate participants and to force them, to motivate them to the rational behavior, already allows us to talk about the possibility of a practical solution to this problem. However, research in this area continues to be actively conducted. Also, there is a problem of blockchain interoperability. the interaction between different blockchain networks, since the transfer of the information from one distributed ledger to another usually requires the participation of some centralized middleman. However, even now, projects such as Polkadot, Cosmos, and Lisk are trying to solve this problem in a decentralized way, allowing different blockchains to interact with each other without any centralized intermediaries. Also, the internal problems of the technology can include the problem of design, both in context of architectural issues, of designing the products, and in more applied sense at the UI and UX level. Unfortunately, today, many decentralized protocols remain products built by developers for developers, and the lack of user-friendly interface, as well as the incredible high cost of error, since the user is fully responsible for the data and the funds, basically frighten away a significant part of the audience that could benefit from using such products. However, the increasing integration of cryptocurrencies into the traditional economy leads us to the fact that more and more products are beginning to give priority not only to functionality, but also to user experience. So this problem can be clearly attributed to the problems of growth, which will soon be overcome. Let's face two of the main external problems, because another obstacle to the widespread adoption of the DLT is basically the lack of the specialists on the market, caused by a lack of training programs for the trading of new and retrading the old personnel. Also, some universities or private companies have already successfully implemented such courses, including, for example, the HSE, which is one of the first educational institutions in Russia who integrated courses of on distributed ledger, the use of the blockchain in corporate governance, and even the DeFi ecosystem. And graduates are becoming the creators of world-class products, but nevertheless, the general lack of specialists on the market slows down the pace of development of the entire ecosystem very much. And finally, last but not least, the problem of state regulation of the entire industry. Basically, so far, there is not a single jurisdiction where cryptocurrencies will be fully integrated into the traditional economy. And I'm not speaking about the smart contracts or the tokenization. However, today states are firmly beginning to understand the benefits that DLT brings with it, and the speed of integration allows us to hope that in the coming decade, not only cryptocurrencies will become a convenient asset with a clear legal and understandable framework, but also the DLT as a technology will be successfully integrated into a variety of aspects of life, including the management of the communities, businesses, and even cities and states. For example, even today, governments of many countries are actively researching the ways of using the DLT for so-called central bank digital currencies, which in the near future can become the new and the only format of money. So basically, to sum everything up, right now we are on the verge of the global change, because right before our eyes is unfolding the fourth industrial revolution, and DLT is clearly a technology that has the potential to change the face of human interaction, of human relationships in various aspects of our lives, making them more convenient, more transparent, and more effective. And basically, we're lucky enough to observe the whole process with our own eyes. And it's a great success that all the problems that stand in the way of mass adoption of DLT technology can be attributed to only the growth problems that will be solved in the near future. And our mission is just to help this process. Thanks.
Thank you very much, Denis. You also had a question which you wanted to ask, Thomas.
Yes.
Yeah, so please, and then,
Thomas, thank you a lot for your presentation. And my question was about the hybrid legal entities. For example, the combination of a decentralized organization and the traditional LLC. So, for example, right now, a law is being passed in the state of Wyoming that will allow the DAO to manage the traditional legal entity. So what's your opinion when similar solution will appear in other countries, including Liechtenstein?
I think that's an interesting approach. I think there are at the moment quite a lot of questions when it comes to DAOs and for example, an LLC. I mean, what you can do is, for example, you can, and I will tell you where the problems come from. Because today you can found not an LLC, but let's say a limited that you can issue the shares in a fully digital way. So what you could actually do is found a limited and say like all of the token holders are shareholders of the company. That's possible, and then you can actually say let's form a DAO based on that and do whatever. But the problem is compliance. Because in the end, whatever organization you're building, you have the problem of complying with anti-money laundering, KYC, counter-fighting of financing of terrorism. So you have to comply with these rules. So the thing is that, like until now, it was just very hard to find someone to actually regulate from a supervisory point of view, But as soon as you define something legally, you always have to have a way to identify the responsible person to hold somebody liable, So the question is, how much of the interesting new concept is actually losing his innovative potential when you try to combine it with a concept we have from a legal point of view, And here it is the same. I think that's very challenging, and I think the limiting factor what we see here, especially in Europe, is that the compliance rules are so strict that this is the showstopper in most cases. From a corporate point of view, that would be very easy. I mean, when we talk about bearer shares, and some years ago, it was no problem to have bearer shares in Europe. It was very easy. You can transfer a share just with transfer of the physical paper, And so the company, whenever you wanted to claim dividend or whatever, you just present that security document and you got it, So that back then it would be easy. But why did that change? Because of compliance. Now, bearer shares are actually immobilized, and therefore you cannot use them anymore. You have to have a registry, and everybody who wants to be a shareholder has to get identified first, has to get whitelisted first. So I think that's the showstopper there. And it's very interesting that the US is actually providing such a model, actually.
Thank you.
Thank you very much. So, colleagues, any questions to Denis? What I would like to say, oh yes, there is one question, yes, from Yegor Sedov. Yes, Yegor, please.
Yeah, thank you. I have a question to Denis, according to his presentation. Well, how do you think, Denis, these problems, especially external ones, are solved in Russia? I mean, besides new educational programs that you talk about in HCE too, and what is the potential for solving them, especially external problems? So maybe how long do you think it will take to solve, for example, the problem of lack of professional workers on the market in Russia? So,
yeah, thank you for your question. Well, I don't think that will takes very much time, because the programs about the blockchain have started just a couple of years ago. So basically, the course about the DeFi, the first one was just last year. So I think the interest from the students, the interest from the professionals is so high, and basically that's because the industry is growing rapidly fast. So I hope that in upcoming years we'll see an enormous amount of fresh blood on the market. So I just hope it, and I think that many other institutions will try to teach the new students. And speaking about the governance issues, well, as I said, the DLT as a technology, the governance, it's quite interesting in using it, because basically it's a foundation for creating the new kind of money, the CBDC, the central bank digital currencies that can be used as the new format of the money. And right now, every country, I think every country in the world, and Russia as well, is trying to develop something based on the CBDC. And creating the new workers' place will attract new professionals, which will then emerge on the market, I think. So I think these two problems will be solved not in the upcoming decade, but in the upcoming years, I think 3 to 5. I hope so.
Thank you very much. So, colleagues, what I would like to say is that, we spent more than 2 hours already discussing, I think, very hot, interesting topics from really multidisciplinary, sides, right? And I once more appreciate your participation. I'm sure that, YouTube video will be, very let's say, interesting afterwards, right? And very popular among the different types of auditories, right? Initially I wanted to, let's say, to conclude, right, to define some, challenges which we discussed, but I think I will not do that. Why? Because actually from each presentation, so there were different challenges, focused on different areas. And I'm sure that listeners and audience, right, they will find those challenges which probably they would like to sort out, or in solving which, right, they would like to participate. The only thing, so I would like to say that distributed ledger technology is not a hype anymore. It's a really, it's a really practical solution for different problems, especially with the high, level of development of digital assets and new digital products, right? And probably soon, distributed ledger technology will definitely be, comply with the copyrights or some other issues, right? We will see. But in general, the tendency in development, right, of the technology is very high comparing to what we had like 5 years ago, right? And it's more deep in terms of technological details. It's more deep in terms of legal aspects. It's more deep in terms of particular applications. And as let's say, digital technology, right, definitely there will be some leading industries or leading sectors where DLT will be probably faster implemented, and there will be industries which will just try to, to take some experience from other industries. I would like to thank you once more. I don't know, colleagues, speakers, right? The rest, because I know some left because of the timeline. Yes, I'm very sorry that we extended the roundtable, longer than expected. If you would like to share some of your thoughts, so please, like 1 minute, to share, and then I think we will finish for today.
Thanks for the thanks, and I guess we all want to thank you, Mikhail, to put this roundtable together and to have invited all of us, and I really enjoyed the discussion, and thank you guys.
Yeah, I also say thank you for having me, and I'm pretty sure I'm going to rewatch the whole video on YouTube again because there were so many interesting ideas, and yeah, thank you again for making this possible.
Yeah, thank you again as well from my side. It was very fruitful, and I think very, very knowledgeable people here. So it was really a pleasure to join your talk. Thank you very much.
Thank you very much, Mikhail, for this amazing discussion. A very great combination of different persons with too many aspects. It was really brilliant. Thank you very much.
So thank you very much, colleagues, and then we'll stay in touch, and we continue hard, work, bringing DLT, to their, to the wider audience, right? Thank you, colleagues, and have a great weekend.
Nice weekend, and
Thank you. Have a great weekend.
Bye.
Bye-bye.
Thank you. Bye-bye.